let's solve one more interesting question. So here we have the question: if x upon q plus r minus p equals to y upon r plus p minus q equals to z upon p plus q minus r, we have to show that this supposition is true. So first what we will do is, first we will apply the rule that we have already talked about, that is, if a plus b equals to c plus d, a plus b equals to c plus d, both of them are equal to the sum of numerators by sum of denominators, that is a plus c by b plus d. And when we have a number of these, each of these is equal to, each of the results are equal to each other. That also we have discussed. So now let's solve the question. We have the following data. First we will have to convert each of them into a 2 numerator 1 denominator system. That is, first we will add the first two, that is x plus y upon this, these would cancel each other and we will have 2r. So you see there are 2 numerators and 1 denominator. That's always easier. Equals to y plus z upon 2q equals to z plus x upon 2p. Is this true? No. So what we have would be, here we will have p and this here we will have q. Now we will find not the term but only this part. So q minus r, so first of all we will invert them and multiply by 2 first. So into 2 we have, by inversion we have equals to p by y plus z equals to q by x plus z. All of these is assumingly equal to k. Now we will add first two, we will subtract first two. So we have r minus p by x minus z, but this is not equal to this. This is equal to this or to the other terms, we just find. That is p minus q divided by y minus x, that is again equal to q minus r divided by x minus z. This is equal to k. Therefore we have r minus p by x minus z equal to k. Therefore we can have and we have thus that r minus p equals to k into x minus z, x minus z into k. Similarly we will find for p minus q and q minus r. As all of them are cyclic, we have p, q and r here, x, y and z here, which correspond to each other. So when we take x here, we take these two here. That is, when we take x here, we are taking p here, and for z we are taking r. Therefore for x, as we take p, for p we will take x. So we have x and minus we have on this hand y, that is k. Similarly this is z minus y into k. Now what we have to do is multiply each of them by the respective terms. So for p minus q we need z, so we will multiply by z, and here also. Now for r minus p we require y. Consequently for q minus r we would require x. Now we will add these all sum up to the LHS of this. Similarly to the RHS, we have k, we will take common in RHS, and we have xy minus yz plus yz minus xz minus yx plus xz. That corresponds to each other, so we can cut them, cancel them, and we get RHS equals to 0, which is what we require. Hence proven. Thank you.